Okay, so we'll get started. Um, Thanks again for joining us. So this panel is about digital twins, and when I talk about digital twins to people, not necessarily in the wireless community but outside, people always ask, "Say what?" Say they don't know what digital twin is, and so that's on one side. On the other side, the word digital twin is being thrown around and misused and overused and etc., right? So one of the missions of this, the experts here, which who will be introducing, will be to make us understand what digital twins are, and how they are being used today, what we see the future of digital twins, and how they may be transforming not only wireless but beyond. So I'll start off the panel. I'm Sujit Day. You have heard me before. I'm the director of CWC. I'm also a professor at UC San Diego, Jacobs School of Engineering. I myself have been working on digital twins for quite some time in various different areas. Digital twins is something that is being used in various different sectors, as you can imagine. I have created digital twins, that is my students have created digital twins. I had to make that clarification, area of transportation, mobility, and so on. Lately, we have started a project creating digital twins with Keysight and having some collaboration with Verizon also. And I have also created digital twins in the health sector, and I'm commercializing that technology through a company called Cipra.ai. So with that background, I'm personally very interested in digital twin, and we have got a set of very distinguished panelists who have been working on digital twins and using digital twins. What I would like is each of you, instead of me introducing, give a quick 90-second introduction of yourself, but also relate to the audience about why you are here, what is it that you are doing with digital twins, or creating digital twins, using digital twins, etc. Thank you.
Thank you, Sujit. So my name is Rajat Prakash. I'm with Qualcomm and I'm working in digital twin research. Professionally, my background has been in wireless research, wireless standards, all the way back to 4G, 5G, and now looking at digital twin. And the reason digital twin is interesting is when we look at, for example, the theme of the workshop today, which is wireless in the era of AI. AI is intrinsically tied to data modeling. How do you use that data, particularly at scale? And digital twin is a sort of a way of thinking about problems where once you have a lot of data, it helps you organize a solution in a systematic way to use that data to then generate value, whether it's all the engineering problems we have heard about today, whether it's throughput, latency, energy efficiency, and so on. So generally my interest is how do we use digital twin as a way of thinking to attack problems at different layers of the stack, especially within wireless networks. But overall, digital twin as a way of thinking applies to various sectors, even outside wireless, and in fact has been used in other sectors well before people in wireless were thinking about it.
Thanks. Tommaso?
Yeah. So, welcome everybody. My name is Tommaso Palermo. Yeah. It's better?
Yes.
Yeah, sounds better. So welcome everybody. My name is Tommaso Palermo. I'm a principal architect at NVIDIA, or the chief engineer for the digital twin at NVIDIA. In a way or another, I've been actually involved with digital twins all my career. At that time, we didn't call them digital twins. There were other names for that. At some point, it was called deterministic channel modeling, or there was called virtual drive testing. And across all of my career, actually, I saw all the pieces move together and come together. And today, essentially, is the moment in which there is this panel. So all the pieces of the puzzles are coming together. Digital twins are heavily overloaded as a term, And across all of my career, essentially, what I tried to do was to study each one of the pieces of that. And I had opportunities actually to focus really for years on some of them. And we have put together a lot of these pieces inside NVIDIA. We're offering a platform for studying this. We're offering source code for academia, also for non-commercial licenses. You can play with it. And today I'll try more or less to tell you what's my experience about all of this, where the industry is going, what are the strengths that we have across all of us, and how fundamentally there is a lot of opportunities for companies adjacent to wireless networks and all of this to start actually generating revenue on this new sort of frameworks that we're building in all of this.
So we'll definitely get to the utility of digital twins, the monetization and so on in the rest of the panel. Rajiv?
Thank you, Sujit. It's a pleasure to be here. Rajiv Bagrodia. I'm a lead technologist for network digital twins at Keysight Technologies. Prior to this, I was the founder and CEO of a small company called Scalable Network Technologies. For about, prior to the acquisition, we'd been around for about 20 years. And I like what Tommaso said about working in this area for a long time under different names. But I will say this, the first patent that was awarded to Scalable was showing how simulation models of communication networks could be used to control and dynamically change physical networks. Today, I think digital twin is kind of, that's the promised land of digital twins. In terms of where I see the role of digital twins or what I do with digital twins, approach is build it and they will come. We have been involved with developing digital twins of different types of communication networks throughout, at least for the last 25 years or so. Last point, before Sujit accuses me of being a mole, I was a professor of computer science at UCLA, and I'm currently a emeritus professor of UCLA.
Thank you, Rajiv.
Full disclosure.
Yes, full disclosure. John?
Good afternoon. John Macias. I'm an associate fellow at Verizon Wireless. I'm here with this esteemed panel to talk about twins today. But in a unconventional sense, as a wireless provider, we kind of categorize twins in three different ways. The first is as a really free and safe space for automation and optimization, a place where we don't throw sensitive parameters at the whole network all at once. The second as a site twin to understand the inventory, the physical assets of the site. And lastly, and this is very ambitious, is to look at the subscriber or the UE placement in the network, how it interacts with the network, and perhaps someday use an NVIDIA engine to look at it real time.
Thanks, John. Rajiv?
Yeah, Sujit, thank you for having me. Good afternoon. My name is Rajiv. I'm from Honda Research Institute based out in Columbus, Ohio. I'm a chief engineer and lead the software-defined intelligence research domain and team here at Honda Research Institute. Essentially, our team broadly looks at three topics. One is around the cloud continuum, second one being embedded systems, third around informative data. Now, the basic premise of our research is founded on this big idea that the mobility ecosystem is a very complex system of various participants that are either working together or trying to work together. And these systems could be your car systems, buses, train systems, road infrastructure, traffic systems, and whatnot, energy systems combined. And the idea is that each of these systems in an ecosystem are becoming much more intelligent with the penetration of software, thereby producing a lot more exponential amounts of data. Now, this data at an aggregated ecosystem level is sort of creating this new opportunity of intelligence that can be tapped into to really solve much more broader societal problems that Honda is interested in, things around connectedness of communities, your automation at scale, think about safety, and then even the environmental challenges that come about. And digital twins is a technology that we have been looking at much deeply, both from a mobility viewpoint, energy systems viewpoint, and then hopefully in the near future from a connectivity viewpoint. That's a parameter that we would like to add as well. And I'd be happy to share more information during the panel discussion too.
Thanks, Rajiv. So I'm going to now challenge the panelists with hard questions. That's what my role should be. And because this Rajiv disclosed that he was an academician before, a professor before, I'm going to challenge him. Explain to us, Rajiv, very, very clearly, what is the difference between a digital twin and a simulation model?
Excellent. Thank you. My favorite type of question.
Oh, okay.
I could talk about it for 2 hours, but I'll do it in 2 minutes.
Now, that's the danger, right?
Academician, you said.
Yeah.
So there are 3 terms that I think are used interchangeably a lot: simulation, emulation, digital twins. And I'll put a concise distinction among them. Simulation, the goal of a simulation is to predict the behavior of the system that it's modeling. Simulations tend to be somewhat abstract. Emulation, the goal is to replace the system that it's modeling. They tend to be much higher fidelity. Simulations typically run much faster than real time, or they can, if they're very high fidelity in large systems, they can run slower than real time. Emulations typically run at real time. Emulations can be software or hardware emulators. Simulations are primarily software. Digital twin can be either a simulation or an emulation. But the most important point about a digital twin is that it has either a connection to the physical twin or the ability to connect to the physical twin, and it communicates with some regularity and some fidelity with the corresponding physical twin. So if we think in terms of a Venn diagram, the digital twin can be either a simulation or an emulation or a combination. It can be software or hardware, and of course it can have both hardware emulators and software emulators. The most important distinction is that its interactions with the physical system, those could be bidirectional. It could be fetching information from the physical twin. And then most importantly, in terms of why I think it has such a bright future, is it does some processing or predictions using optimizations in the traditional way, using AI or ML-based systems, to predict a more efficient, more optimized, if you will, something that improves the performance based on the KPIs that are of interest of the corresponding system.
Thanks, Rajiv. So this is very concise. So essentially, there is a transaction here between the natural twin, you're calling the physical twin, let me call it the natural twin, and the digital twin. The natural twin has a vested interest in the digital twin. The natural twin can gain from the digital twin.
Absolutely.
Can trust the digital twin.
It must.
Okay, good. Okay, so now tell me, besides you mentioned that the digital twin interacts with the natural twin. So now let's get back to wireless networks. So in the context of wireless networks, Rajiv and John, for instance, John, let me start with you. So can you validate what Rajiv is saying? That is, does some aspect of the natural twin, in this case, the wireless network, how is it benefiting from the digital twin? Or is the digital twin a nuisance for the actual network?
I'll try to make 2 comparisons that are very valuable to us and validate what you're saying.
Good.
One, there's a tremendous amount of value in having an accurate site inventory, not just for planning purposes and asset tracking and life cycle, but to actually assign a value to the usage of the assets that are in the sites. So we can plan, we can develop, we can decide if we're going to throw out another 5G carrier, maybe C-band, because it was a prolonged time to get that out into the network. We know exactly when to put it, how much it's going to cost, and we can figure out how to roll it out effectively. So it's very valuable. The second is, and I think I mentioned it briefly earlier, is that we will actually choreograph sending out network parameters. So we'll use that digital twin as a means of understanding what it will take to roll things out that are particularly sensitive. We don't want to do a full-scale rollout of something that reduces power when we know will affect customers. So why not use that digital twin to figure out how it's going to affect the network and then roll it out in a much, much more confident manner? So yes, we absolutely use that, the 2 I mentioned previously.
That's great. So Tommaso, going back to you, and yet, digital twins, so Rajiv did a very good job of defining digital twin for us. Now, in your, actually the same question to you, in your worlds, when you are developing, because you guys develop digital twins, So when you are developing digital twins, so for instance, for the network, it's just too many things to develop. How do you focus on what? And so tell me, you're not trying to mimic or interact with the entire network. How are you picking up what you are, for lack of better words now, modeling, because ultimately it's a model. And what are the most important things that you see from a business point of view that we can model, and it'll be important for us to model?
Yeah, I'll try to take a shot at this. So, as I was saying at the beginning, the digital twin is heavily overloaded term, and fundamentally, we see the first split or division within the role of the digital twin into design, deployment, and operations. So operations like network management or network optimization. And depending on which one of these three main branches we're working on, we try essentially to cut the digital twin in a different way. So for us, specifically at NVIDIA, we're very interested in the design part and how a specific digital twin for design is going to intercept their interface design for 6G. This is very central to everything that we do for the digital twin. And therefore, for us, a digital twin is a very strong evolution of what could be a system-level simulator in the same way in which 3GPP would intend it. That's how we see this, with the intention and the roadmap to intercept the operational part after the system has been designed. So the system will be designed and then will be deployed and then will be managed, right? And I think along the way, we want to start by supporting the design phase. And we believe that there is an interest in that part, especially when it comes to the AI native part that is really in-house. And this is essentially what we are really focusing on at NVIDIA, to enable the design, and across the span of this effort, we're going to start transitioning towards, after you have designed it, you want to deploy it. After you have deployed it, you want to manage it. And we're going to evolve the feature set of the digital twin to cover this life cycle of their interface.
And are you doing something that Rajiv mentioned and John also supported, that the digital twin, if it's not to be just a simulation model or emulation model, needs to show this value to the physical twin in terms of interaction or whatever the value is? What do you think of that?
Yeah, so we are definitely in a very fortunate situation at NVIDIA because we have a software-defined radio. And by having a software-defined radio, we are going to have the production stack embedded into the digital twin since day one, since the very beginning, right? So if you have a stack that is based on ASICs or other way of implementing the stack, different layers with different hardware behind it, you might require some modeling effort along the way. But because our solution is purely software and is based on fundamentally a general purpose accelerator for this, we not only have a strong relationship with the natural twin, we actually have the production stack running within the digital twin. It's almost the very same code.
Right.
So this is really the power of software defined.
Right, Raja?
Yeah, so I think there are various aspects to cover. So some of the value of the digital twin, I agree, the AI native air interface, which previously has been discussed today. So the digital twin can be thought of as a training playground for that. So you can create models, test them, validate them, tune them. For example, a model which might work in UCSD campus and a model which works in downtown Manhattan might be a different model. So you could use a digital twin kind of setup to optimize and tune and validate in a digital domain before deploying those models to the field. And in terms of deploying those models to the field, they could be trained in a digital environment and then installed into a base station, which is the ORAN RIC way of thinking. They could be pushed down to the devices. And that's a very strong part of the interaction between the digital twin and the natural twin, in the sense that once the natural twins are incorporating AI in their behavior, the models which are in the natural twin would be trained in the digital twin, or at least validated in the digital twin. So I think that's an important part of the digital twin. And one challenge we see in operationalizing this technology is sort of the twin versus cousin, versus distant relative. Those kind of terms are out there. And often operators are dealing with diverse networks with the equipment suppliers, device side, network side, core network. There's a diversity of suppliers. So how to collect data from these devices, these equipment in the network, and make sure the digital twin is representative. So in the machine learning community, there's this idea of foundation model. And in digital twin, you could think of it as a universal digital twin, or is it a bit more use case specific and a bit more narrow
Application
digital
specific
twin?
digital twin.
Yeah, and that I would say is an area of research. I don't think anyone has a final answer on that, but a very interesting problem to sort of pursue both approaches.
So that brings
Can I
me
add
to yes, go ahead.
I think this concept of use case is very, very important. It's not just about digital twin. Anytime we talk about a model, we talk about a model with respect to an intended use case. The model of a satellite for someone constructing a satellite, digital twin of a satellite, would look very different and focus on very different properties than the digital twin of, let's say, a non-terrestrial network looks at how the satellite is modeled. For the latter, the satellite, all we care about are the antennas, maybe its trajectory. Other than that, it's a point solution. For someone building the satellite, it's just the reverse. And I completely agree with Rajat. I think the art of digital twin is the same as the art of modeling. It's Occam's razor. What we leave out is very important so that we only include those aspects that are most relevant to the KPIs or the intended objective of the digital twin.
That's a very good point. And then to Rajiv, you are an automobile company, but you are much more than an automobile company. And you are working on digital twins, various aspects of it. Tell me about first of all, tell me, are you modeling along with, let's say, a digital twin of an aspect of an automobile or an aspect of mobility? Are you also modeling or creating a digital twin of the environment or a particular use case? How are you doing this? Tell me about, what you are doing specifically in terms of building digital twins and what are the challenges?
Sure. So at Honda, we've had a long history of simulation, to your point. Again, simulation at the product level, right to the nut and bolt level, to crash testing and all sorts of different sorts of testing. But as we're all aware, the whole mobility ecosystem is going through this huge paradigm shift once in 100 years, right? Like the products that we are building today, essentially you need a road, you need a parking place, you need gas stations. You can replicate that product across the nation, across continents, across regions as well. But as this paradigm is changing, we're starting to imagine what future mobility will look like. Will it be more connected? Will there be more integration with private and public mobility or something of that nature? So the idea of from what we are thinking about right now from a digital twin is we really need to understand the mobility characteristics of cities, first of all. And every city has its unique sort of mobility characteristics. For example, here you may have a certain type of subway stations. Columbus, Ohio does not have a train station. And people's mobility patterns change a lot based on the city you're staying in as well. So our whole idea is to sort of first emulate and build out the twin of the city. So really what we're trying to do right now is build out the digital twin of the transportation network in a city, to first emulate how the different systems are moving, how people are moving, how the various participants are moving, where are they going for their different needs, what those things are. And that's what's driving our understanding of first where the bottlenecks in the network are from a transportation viewpoint, like the transportation efficiency. We're starting to see at an aggregate level, what is the environmental impact, right? Like how much are we contributing versus other reasons in the ecosystem? Also social impact, right? Like because of certain mobility solutions, are there parts of the community that are unable to go to their jobs or get access to healthcare? These are future opportunities that we want to get insight about. So that's what we're building at the city level. And this cannot just be Honda alone, which is why we invite sort of government agencies, other participants to join and help build out this at the city scale itself.
That's very important. And you had also mentioned city scale before, in our previous conversation. But going back to this interaction between digital twin, physical twin, so is it fair to say that digital twins also need to interact with each other? So, if you have a digital twin of an automobile or a digital twin of a layer 2 stack, then that needs to interact with other digital twins, maybe the environment, the city, maybe the other stack and so on, right? Has there been, and Rajiv, now to you, because you have been developing digital twin commercially for quite some time, do we have frameworks where digital twins actually can interact with each other? And second question related, I think, is that when I want to use a digital twin, I'm the developer, not the developer, I'm the user of the digital twin. I want to query the digital twin. I want to, query the digital twin because it has a lot of knowledge and understanding. Is that possible today in today's frameworks, today's technology? So one is interactions and the other is query.
Yeah, interaction or composability, if I generalize what you just said, so from a network, I can say there are 3 or 4 parts. You have the digital twin of the network, you have the digital twin of the application, the offered load, the traffic, you have digital twin of the environment in which the network operates, and you kind of compose these together. So you have some kind of a propagation model or the NVIDIA, the name of the NVIDIA product just slipped out. Omniverse, thank you. The NVIDIA Omniverse, and you can certainly compose that with, let's say, the Keysight Exada network model. But to me, the bigger problem, if I step back and say, if network or digital twins are going to be more widespread, the composability of these twins is one of the central and hardest problems. Why? Because a lot of the times they operate on very different timescales. Network protocols, and let's say if you have a digital twin of an antenna design, that's a CAD system. Very different timescales. You have the concept of multi-fidelity models. If you have 1,000 million node network of sensors, very rarely do you want to model all million nodes at the same level of fidelity, because what the heck, what are you going to do with all of that data? You can't even visualize it, do anything with it. You typically need to focus on some subset of that model, which is your critical component for whatever reason, and represent the others at a lower level of fidelity. This concept of multi-fidelity models and how you compose them together, again, I think a very strong research and academic challenge, as well as something that we should address.
I was going to the research side of it because I do want to involve the audience, but before that, I owe it to everyone that what are the research challenges, right? So anyone can take this question that so we can build digital twins using conventional technologies, conventional simulation, emulation technologies, signal processing technologies, and so on, or we can put to bear various AI advances, including generative AI. So so what are the research challenges in creating these digital twins? Can generative AI create digital twins? Has there been study done that like generative AI is taking bar exams and medical exams and so on? Has it created digital twins? Can it create digital twins? What do you think, Tommaso?
Yeah. So
or for you yourself.
Yeah. So
and related to that question is, as researchers, what are the research areas that we should look at in terms of composability of the models, generation of the models, interaction of the models, whatever the issues are? Can you lay it out, you guys, like in a few sentences?
Yeah. So going back to your previous question, at the very least, there should be interconnection between the digital twin for the RAN and digital twin for the UE. That's at the very foundation of everything, right? And it's typically not that easy to be perfect on both sides, right? And for definitely the receiver structure of some type is different from essentially how complexities are located. The other aspect about how generative AI fits into all of this. So I think a large value proposition for the digital twin is shift left, fundamentally. So get to test your design at an early stage before you have invested into hardening your design. So in that sense, I think generative AI is something that allows you to, maybe even in conjunction with a more formalized channel model that is coming to you from the ray tracer, but generative AI will provide you essentially the statistics around it to challenge your design. So I definitely see how generative AI can actually provide an earlier intercept of your design and how you can actually start challenging against that. Things can also be brought to maturation, and then of course you can replace certain parts that are a little bit slower in your design and replace them with a generative AI counterpart.
Quick answer from you, especially on the research side. What are the research problems?
So let me combine the generative AI and the research side. So if you look at, for example, molecular biology, UCSD is a great school for that too. So there's a AlphaFold. You ask it, what if I change this A to C in the DNA sequence? What's the new structure of the protein? It's a generative AI problem driven by data. So a wireless network is maybe not as complex as DNA. Some would argue it is, but still very, very complex. And how do you use generative AI to ask such questions? What if I change my admission control policy a little bit here and there? What would happen to my QoS behavior? So these kind of
then
questions.
you don't need digital twin. Generative AI can do it.
Yeah, so generative AI is inside the digital twin in that case.
Okay.
It's one of the components in there.
In the generative AI, sorry.
No, please.
The generative AI, what you just said, I think is a really key point. You can use the models instead of writing the procedural models in C, C++, etc. Now you can generate these models. These are basically data-driven models. Mm-hmm. And that's where the intersection between generative AI and digital twins becomes even more.
I would like to, we are running out of time. We had 40 minutes and there's so much discussions still to be had. I would like to invite any of you to ask any questions that you have. If you can, I think that hopefully there is someone to give the mic to you. Can you kindly come here? I'm sorry, it takes some effort. And please let us know who you are so that, we have better context and ask your question.
Okay, so it's on. Hi, I'm Liko Wang from Skyworks Solutions. My question is, I really don't know much about digital twins. So what's the ultimate goal? Is the digital twin one day going to be complete enough to replace the physical network? Because if the computing power is there, then why would you need the physical network, right? Are we living in the matrix or, Thank you.
Any of the panelists?
I'm going to say something that will sound very melodramatic. But when I was running my small company, about 10 years ago at one of our company meetings, I said, our competition is Cisco, because if we do our job well enough, the only reason you'll need physical network is to physically send a bit or a byte from point A to point B. For all other planning and, testing and all of those goals, you should be able to use digital twins. So I think you mentioned the one application that digital twins will never accomplish, which is a physical movement. But to be able to control and see how that's done in the most efficient and optimal manner, sure, I think that's where digital twins come.
Any other questions, guys?
Okay, thank you.
Yes, please. And as he is asking the question, can I throw in another question of mine? And that is, will there be a ChatGPT moment for digital twin? 1 year from now, 2 years from now, 3 years from now, guys? What do you think?
saw Rand GPT, didn't we?
Yeah, RANGPT
Right.
time.
I can see
I think we
us
are headed in
asking,
that direction.
Huh?
Yes. We are headed in that
Digital
direction.
twins. So what would make digital twins so usable? See what made ChatGPT successful. I mean, we have been working with AI for, I don't know, 20 years, 30 years. The usability of it, right? So what is it needed for digital twins to become so usable that it gets that ChatGPT moment?
Okay, let me take a shot. When we look at network digital twins specifically for a nationwide network operator, so I think what it takes is some of these, a lot of it is the technology part has some challenges. The ecosystem part also has challenges, especially when it comes to composability of the digital twin. So integrating the 3D model, the base station behavioral model, the device model, traffic model, having good definitions for them from a standard side, ecosystem side. So that coming together with some of the natural progress in ML technology. So I don't know how many years it takes to converge, but I think we're on the right path.
Thanks. Sorry, go ahead.
Neil Smith, I'm here with the Qualcomm Institute. I'm also an anthropologist and computer scientist at the same time. So a question I have for you is, we've talked a lot about simulation, emulation, and digital twins in the world, but we haven't talked about human in the loop, right? So a lot of things we want to find out is how well humans are going to use it. Because usually once you hand over to the humans your product, they usually break it. They don't know how to use it right. So what are your guys' thoughts on how you can include humans in the digital twin simulation and improvement of the system?
Take a shot at that
Yes,
first.
go ahead, sir.
We have a lot of really fantastic service assurance engineers who've been doing this for 20 or 30 years. And they want to be able to do a natural language query to the system based on a digital twin that has a lot of really great information and say, what if I upgraded my backhaul to 10 gig? What would my service look like for everyone? And I have all of my service tickets that are queued in reference to that site and its capabilities. That would be extremely useful to put a human who knew what to ask based on the twins on how that site would perform.
And John, this was a very good example of the difference between digital twin and simulation or emulation model. You never ask a simulation model, Mr. Simulation Model, what if I did this? What if I did that, right?
Right.
So, there's, a huge utility, I think, for digital twins that will come. Other questions? This has been a relatively quiet audience. And I'm also, maybe we are failing to excite you guys, ask questions, or we are being way too clear. No doubts.
We all realize you guys know a lot more about digital twins than we do.
John, you need to come here.
No, I was just going to say it's been very enlightening in terms of the definitional properties of it, because I probably am somewhat guilty of throwing around the term in a somewhat overloaded sense. So I guess as you guys have outlined the research challenges, and then you kind of alluded to generative AI, I guess, residing inside the digital twin, and maybe that's also part of the definitional difference relative to a simulation. I guess when each of your companies and even from the academic side, when you're looking at use cases, do you see digital twin being directly monetized, or it needs to be monetized via other, other things brought with it?
Alice?
So I believe strongly that digital twins are themselves a direct vehicle for monetization. I think John's example was great. From a, let's say, service provider, from an internal use, it could increase and improve the productivity. If you take the next step and say, if I have, let's take a very simple example of beam selection in a massive distributed MIMO context, with multiple UEs moving in different ways, or a cell-free, network, different cases in which you have multiple ways of servicing multiple users. We could create an AI ML system that is trained well to be able to aid in the selection of the beams. Digital twins will play a significant role both in terms of testing such a tool, in terms of training such a tool, and finally, if you have such an AI system embedded in the digital twin of the type that John was talking about, the productivity boost would be even more significant. There is a a certain amount of work to Sujit's thing. That maybe not the Chat GPT moment, but still the tipping point where its usability has been demonstrated. And just last point I'd make to make the Achilles heel that I see with that is a lot more work needs to be done to validate these digital twins in a meaningful manner. And that's where some amount of it's not a cheap, inexpensive, task. And that's where some amount of effort needs to be put.
Okay, thank you very much. I see that we have run out of time. Thank you to every one of you. And thanks to you for participation.
Thank you.